magnetic dipole. When it is placed in uniform magnetic field. Now you can see here, this is a region of uniform magnetic field. And here there is a dipole which placed in such a way that the magnetic moment vector makes an angle theta from the direction of magnetic field. This is the magnetic moment vector, which is always directed from south pole to the north pole. And it is making what angle from the direction of magnetic field? So here it is making theta angle from the direction of magnetic. So how much torque will act upon it? So we can here that find the formula exactly using the formula of the electric dipole. In case of electric dipole, this formula is tau equals to vector P cross vector E. Here it will be tau equals to vector M cross vector B. P के place पर क्या ले लेंगे? M लेंगे. So when you will write tau equals to mv sin theta, this will be the magnitude. Now case 1, which I have explained yesterday, when theta equals to 0 degree. Theta equals to 0 degree means now the magnet is placed in such a way that the magnetic moment vector and magnetic field vector both are parallel. Magnetic moment vector and magnetic field vector both are parallel. In this case, tau equals to mb sin theta, 90 degree, sin 0 degree, sin 0 degree. And sin 0 is 0, therefore it will be 0. Means no torque will act on the, no torque will act on the dipole. Dipole पर कोई भी torque act नहीं करेगा. And it will be in the stable equilibrium. It will be in stable equilibrium position. Means from this position, if you apply the external torque, it will come to the new position. External torque means you have applied the torque. See here, you can see in the diagram here. What is the meaning of stable equilibrium here? Here dipole is placed in this way. Initially it is placed external torque in anti-clockwise direction. It will come to this type of position. Means now it will come in this position. In this position means here I am representing that position. Now as soon as it comes in this position, now vector M and vector B will be no more parallel. Vector M and vector B will be no more parallel. And a torque will set up upon it because of the magnetic field. A torque will set up upon it because of the magnetic field. And what will be the tendency of that torque? उस स्टार की टेंडेंसी क्या होगी जो मैग्नेटिक फील्ड के कारण इस पर एक्ट करेगा? इट विल ट्राई टू रोटेट इन द क्लॉकवाइज डायरेक्शन, मींस अपोजिट टू द एक्सटर्नल टार्क. So if you remove this, what will happen? Because of this torque, once again it will come to the same position. Once again it will return to the same position. This is the stable equilibrium position. Stable equilibrium position. Now see here case 2. If theta equals to 180 degree. 180 degree means, you can see here, earlier it was kept in this way, but now it is kept in this way. Magnetic moment vector is directed in this direction, and magnetic field vector opposite to that. Means vector M and vector B both are anti-parallel. Anti-parallel means what is the angle between them? 180 degree. Vector M and vector B, anti-parallel. What will be tau? Once again, tau will be 0 because sine 180 degree is 0, and this will be the unstable equilibrium position. Equilibrium position of dipole. And see here, what is the meaning of unstable? Now you will find that if you remove the external torque, it will not come back to the original position. If you remove the external torque, it will not come back to the original position. You can see here. Now the magnet is placed in this way. Its south pole is in this side, north pole is in this side, and this is the direction of the magnetic moment. It is clear. When you apply an external torque here in anti-clockwise direction, tau external, it will come to the new position. What will be the new position? This. What is the direction of magnetic moment? Magnetic moment direction is no more parallel to the magnetic field. Now, because of the magnetic field, a torque will act upon it. Because of the magnetic field, a torque will act upon it. And this torque will act in what direction? This is vector M and this is the vector B in this direction. So it will act in the same direction as the direction of external torque. External torque is acting anti-clockwise. Torque due to magnetic field will also act in anti-clockwise. So if we remove this torque, what will happen? Still it is acting. This torque is still acting and it will come to the new position. So this is the unstable equilibrium position. Now see the case 3. From which we will reduce the definition of the magnetic moment. Now case 3. Theta equals to 90 degree. Theta equals to 90 degree means if you picturize this thing, it will be like this. This is the magnetic field and This is the magnetic based industry. This is the direction of magnetic moment and magnetic field is in distance. What is the angle? Angle in 90 degree. Theta equals to 90, so tau equals to mb sine 90. And sine 90 degree equals to 1. And 1 is the maximum value of sine theta. Therefore, maximum torque will act upon the dipole. Dipole experiences maximum torque. Experiences maximum torque under this condition. Under this condition. Under this condition, it will experience maximum torque. Now, from here, we can deduce the definition of magnetic moment M. What is magnetic moment? It is tau max upon B. Now, suppose this magnetic
सर
is
माइक
in the
ऑफ है आपका।
uniform magnetic field of unit strength perpendicularly. Therefore, magnetic moment of magnetic dipole is equal to maximum torque acting on dipole when it is placed in uniform magnetic field of unit strength. Unit strength means 1 Tesla. Unit strength. Perpendicularly. Perpendicularly. This is the definition of magnetic moment. Definition of magnetic moment. Now from here we can deduce the SI unit of magnetic moment. So if you see here, what will be the SI unit of magnetic moment? So tau equals to mb sine theta. So what will be m? It will be tau upon b sine theta. Now if you see here, tau is Newton meter and B is what? Newton per ampere per meter. Sine theta don't have any unit. So Newton and Newton will cut. This is per ampere per meter, it will go up. So it is ampere meter into meter. That is ampere meter square. Now, what will be its dimensional formula? Who can tell its dimensional formula? Can you tell the dimensional formula? Wait for a minute. So you can see here, its dimensional formula will be AL square. This will be fundamental unit. This is also fundamental unit. So it is AL square. This will be the dimensional formula. So